Exercise 4. Find the coordinates of the turning points of the function f of x. So we don't have a calculator, so we understand that there are two turning points. This is an x3 type of curve, so this looks probably something like this. Okay, so it has two turning points. This is a local maximum, or we just call it a maximum. This is a local minimum, or we just call it a minimum. And they would like to know the coordinates of the two turning points. So the coordinates, the x and the y coordinate for this minimum and for this maximum and for this minimum. Okay, let's start from the beginning. F of x is equal to x3 minus 9x2, x3 minus 9x2 plus 15x. So one thing that we can use the derivative for is to find the slope of the tangent. Okay, the tangent to the curve. So for example, if we choose this point, the tangent would be more or less like this. Okay, very steep. If we choose this point, the tangent would be something like this. If we choose this point, which is the local maximum, it's going to be completely horizontal. And the slope of a horizontal line is 0. Okay? So when we know this, we can use that to find the coordinates for these two turning points. Same thing here. At the minimum, this tangent is going to have the slope 0. So that's what we need to find out. So first of all, let's find the derivative. So if this is y, then we can say that dy dx, the derivative of y with respect to x, is equal to. Now you have to remember the rule. You take the exponent, move it in front. You have it says just 1 times x is 3 times 1. 3, then times x, and you decrease the exponent by 1, so we have to the power of 2. Then we take this 2, move it in front, minus 9, that is already there, times the 2 is minus 18. And then we take x and decrease it by 1, so we get to the power 1. But we usually don't write it out, so we just write x. And then we take the exponent, that is really 1, that we don't write out. Take the 1, multiply with a 15, we get plus 15. And then what we really get is times x to the power of 0. But anything to the power of 0 is equal to 1. So this is really 15 times 1, which is 15. So when we have something, an x term, like this, 15x, the derivative is 15. If it would be 37x, the derivative would be 37. If we would have minus 3.7x, the derivative would be minus 3.7. Okay, it's gonna be easy to remember that rule. Okay, this is kind of the function, the derivative function that describes for different values of x the slope of the tangent. Remember, we want the slope, which is this, the whole expression, we want that to be equal to 0. So we would like to solve this equation. Solve dy dx is equal to 0. When is this equal to 0? For which value of x does this happen? So when is 3x squared minus 18x plus 15 equal to 0? Let's get some more space here. Okay, this is the equation. It's already set up for using the general formula. It's difficult to factorize this, so we have to use the general formula. A is the constant in front of the x2 term, so it's going to be A is equal to 3, and then B is equal to minus 18, and then the C is equal to 15. Okay, x is equal to minus b, which is minus 18, which is 18, plus minus b squared, which is minus 18, this under the root, minus 18 squared, minus 4 times a, which is 3, times c, which is 15. Okay, we're going to get some big numbers here. Let's see. Everything divided by 2a, which is 2 times 3. Let's clean it up a little bit. This is equal to 18 plus minus 18 squared. Maybe it's, oh sorry, minus 18 squared. Maybe it's a little bit difficult to do in your head, so we'll just do this, 18 times 18, which is the same thing as 18 squared, which is the same with minus 18 squared. It's going to be positive anyway. 8 times 8, 64, carry 6, 1 times 8 is 8, plus 6 is 14, 1 times 8 is 8, 1 times 1 is 1. 4 plus 8 is 12. Oops. 12, carry 1, 1 plus 1 plus 1, 3. 324. Square root of 324 minus, I'll do minus 4 times 15 first. This is 60. 60 times 3 is 180, and the minus sign, so minus 180. And then divided by 2 times 3 is divided by 6. Let's continue down here. So hopefully we get some nice numbers in the end, since this is without the calculator. 18 plus minus square root of, what is this? 324 minus 180. If you do it, work it out in your head. I think I started at 200, so from 200 to 324, I have 124, and then I actually missed 20 up to 200 where I started, so I have to add 20. This is 144. And this is going to be, well, square root of 144 is equal to 12, so we get some nice numbers in the end. Is equal to 18 plus minus 12 divided by 6. And now we get two solutions. The first one is 18 plus 12, which is 30. So 30 divided by 6 is equal to 5. That's the first value of x. 18 minus 12 divided by 6 is equal to 18 minus 12 is 6 divided by 6 is equal to 1. This is the general formula. Could we have done it in a different way? Actually, if you look at this, we can factorize this. 3, you can find a 3 in everything. X squared minus 6x plus 5 is equal to 0. Now, this factor times this factor is equal to 0. Either the 3 is equal to 0, which never happens, Or this factor, x2 minus 6x plus 5 is equal to 0. So we just solve that equation and we can find the factors 1 and 5. And if we take minus 1 and minus 5, then we get minus 6x here and we get plus 5. So we could actually guess the roots. But I wanted you to practice the general formula. That always works. Now back to the question. Find the coordinates of the turning points. Okay, so we have the x values. We would like to have the y values now. So we just have to plug in these values into the main function. So let's use that. This is the function x3 minus 9x2 plus 15x. So let's find f of, and let's use 5 and 1. So f of 5 is equal to, and then f of 1 is equal to 5 cubed minus 9 times 5 squared plus 15 times 5 is equal to 125 minus 9 times 25. What is 9 times 25? It's minus 225, and then plus 15 times 5 is plus 75. This is equal to minus is equal to, so this and this makes 200 minus 225 is equal to minus 25. So that's the y value, y coordinate when the x coordinate is 5. 1, and that's going to be a little bit easier, 1 cubed minus, I'm looking at this function, 9 times 1 squared plus 15 times 1. So this is equal to 1 minus 9 plus 15. Okay, so 1 plus 15, 16 minus 9 is equal to, let's see if I can get this. Yeah, it doesn't matter. So what do you say? 1 plus 15 is 16, minus 9 is 7. So this is the y coordinate and this is the x coordinate. Okay? Now, the answer would be, this is the one of the points, 5 minus 25. And the second one would be 1, comma 7. Now, even though this is not a calculator exercise, let's draw the graph just to check the result, and we practice that with a calculator. So x cubed, remember to go down from the exponent, x cubed minus 9 x squared, and then plus 15x. This is how it looks like. I'm gonna zoom out a little bit so I see the turning points. Zoom out once again around here. Now I see the two turning points. Escape to go out of zoom mode. I'm going to use the box zoom. Choose this corner and then this corner. So I just see the curve, this part of the curve, which is interesting to me. So let's analyze the graph and find the maximum. Go a little bit to the left, go a little bit to the right. 1, 7. What did we get? 1,7. Menu, analyze graph, and the minimum, let's go a little bit to the left, a little bit to the right. We have 5 minus 25, and we got 5 minus 25.